Greetings and welcome, ladies and gentlemen. We're taking a look at last night's homework. We were specifically targeting just word problems related to systems. And here's one on problem page 70, problem 10. It says, Home Pride manufactures solid oak racks for displaying baseball equipment and karate belts. Wow. They usually sell 6 times as many baseball racks as karate belt racks. The net profit is different, by the way, than revenue. Profit is the money that the business gets to keep. Revenue is the money the business earns, but it does not cover the cost of manufacturing. So let's see. The net profit is $3 from each baseball rack and $5 from each karate belt rack. If the company wants total profit of blah, how many? Oh, here's our question. How many of each type of rack should they sell? Right there. So my variables, I could say X is the number of B-ball racks, right? And Y is the number of, I believe it's pronounced karate racks. So there's my variables. Now let's see if we can write some equations relating these things. So it says they sell 6 times as many baseball racks as karate racks there, right? So, so the number of baseball racks relates somehow to the number of karate racks, right? So is y equal to 6x or is x equal to 6y? Right? Because the number of baseball is equal to 6 times the number of karate. Okay, so it's usually good to kind of say that out loud in your head at least a couple times just to make sure it logically matches what we were going for. Let's see, the next fact I know is that the net profit, okay, so profit, and I know my total profit desires, right? So let's see, if the total profit is 46,000, what terms would make up that 46,000? How could I, what's that $3 do for me? I earned $3 for every what?
So would you get like 3 racks?
Yeah, right? $3 for every baseball rack. Hey, I have a way to say that. X. So 3 times X. This would represent the total profit coming in from all of the baseball racks. Plus, and then I earn, yeah, plus 5y. So that right there looks like a system. I've got 2 equations, 2 unknowns, right? So all sorts of good stuff. So I can solve that. In fact, it looks like I might solve by substitution. It looks like my top equation is already solved for x. So I might as well just start subbing. So 3 times 6y plus 5y equals 46000. So that's going to be 18y plus 5y equals 46000. That is a total of 23 y's, if I'm not mistaken. Oh, 23 y's. And then divide both sides by 23. And what is that? Is that 20,000? Did I do that right? Yeah, or 2,000. 2,000. There we go. Oh, I'll just redo some of those. Bam. Is it 2,000? Yeah. 2, yeah, and then 3 zeros. Sounds good to me. So in order to find my other solution, the other half of it rather, what should I do with this 2,000? Yeah, I happen to like this one because it's already solved for x. So x equals 6 times 2,000. So x equals 12,000. And then we could answer the question with a sentence. Let's see. So they must sell. Well, actually, wait. Is 12,000 the money they made? What does 12,000 represent?
They should.
The number of baseball racks they need to sell, right? So that's not profit, right? So that's one of the values of defining your variables, is then you can answer the question a little better. They must sell 12,000 baseball racks and 2,000 karate racks. Bam, answered. So let's see. Let's look at, what is it? Was that one on page 76, the physics one? It sounded like a good one to me. So this used some perhaps less familiar variable names here. Let's see if I can get a clear snapshot of this. Kaplow. Yeah, I can fit it on this one side here. Blah, 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 blah. There we go. So, all right, I'm not even going to read all of this yet. Let's just start by figuring out, all right, we got to find our variables, right? So our variables are likely related to, well, actually, maybe we will have to read this. We'll see. I'll read it. The height of an object is thrown upward with a constant acceleration of a feet per second is given by the equation blah. All right, so it looks like they gave us an equation, which if you've taken physics, perhaps you recognize that. A is typically 9.8 meters per second squared in meters, and it is, yeah, typically the 32 feet per second squared in feet, right? Depending on what unit of measure you're using. T is time, V naught or V sub O. Let's see, where's my cursor? It's hard to spot it in the morning. V sub O happens to be your initial velocity, and S sub O or S naught is your initial height. Okay, or what those variables represent. It says the height is s feet, t represents time in seconds, v naught is the initial velocity in feet per second, and s naught is the initial height in feet. Okay, so this s, man, I really can't see my cursor. There it is. This s is the height at a given time. So this equation is really written in terms of those variables. It says find the acceleration, the initial velocity, and the initial height if the height at 1 second is 75 feet, the height at 2.5 seconds is 75 feet, and the height at 4 seconds is 3 feet. Okay, so we've got three variables. I need to find A, which is the acceleration. I need to find V naught, which is the initial velocity. Nope, I just spelled that wrong. And I need to find S naught, which is the initial height. Okay, so my equations are all related to this guy, and I'm going to plug in the little facts they gave us. They gave us three facts. So they said the height at 1 second is 75 feet. So that means 75 is equal to 1/2 a times 1 squared plus v naught times 1 plus s naught, if I'm not mistaken. It says that the height is 75 feet at 2.5 seconds. So 75 equals 1/2 a times 2.5 squared plus v naught times 2.5 plus s naught. And the last fact they gave us is that the height at 4 seconds is 3 feet. So it looks like it's probably going downhill at this point. 4 seconds, right? Yeah, 4 squared plus v naught times 4 plus s naught. So notice I have 3 equations and 3 unknowns. You know, this may end up having to go on the next slide or screen. We'll see. So to solve this, well, I first would recommend that maybe we simplify some of these. So let's see, this top one, this is the same as, let's see, 1 squared is 1, half of 1 is 0.5. So I'd have 0.5a plus v naught plus s naught equals 75. Notice I just kind of switched it around into the order we're more comfortable with. The next one, 2.5 squared, is that 6.25 times 2 would be that 3.125. Did I do that right? I'm going to verify that just to make sure. I've still got a little summer. 6.25 divided by 3.125. Wow, nice. I still got it, guys. I still got it. Plus 2.5 v naught plus s naught equals 75. Right. And let's see, the last one, 4 squared is 16, half of that is 8. So 8a plus 4 v naught plus s naught equals 3. So looking at these equations, what is your desire? How do you want to solve this?
We eliminate.
Yeah, I think I'm going to probably go by elimination here myself. Although substitution, notice all of these s naughts have a single variable. Actually, there's a v naught as well with a 1 in front of it. So those are all okay if you were to solve by substitution. I think I'm going to use elimination though. So if this is A, B, and C, I'm going to go for opposite s naughts. And because in equation B, most of my coefficients are larger than the ones in equation A, I'm going to make A my negative 1. So I'm going to multiply A times negative 1 to get a negative s naught to cancel out with this positive s naught. And then it looks like the 75s will cancel out nicely and blah, blah, blah. So let's see. So that would be negative 0.5a plus, or nope, minus v naught minus s naught equals negative 75, not 57. So let's see. Then I'll have, what's this? B minus 1a. So to do that, I'll have 3.125 a's minus 0.5a. So what's that going to be? 2.625? Did I do that right? I'm doing this minus that. 2.625. Verified. A. 2.5 v naughts minus 1 v naught would be plus 1.5 v naughts. Right? Just subtracting the coefficients. And then s naught minus s naught is snot. 0 snots. And let's see, 75 minus 75 is 0 there as well. Okay, so now how can I, let's see, I've gotten rid of one s naught. I've gotten rid of this one. How could I get rid of this one here?
Don't you add negative 1a to c?
Sure, I like it. I like it a lot. So let's see, I'll have c minus 1a now. So I'll have 8a minus 0.5a, that's going to be 7.5 a's, plus 4 v naughts minus, 4 v naughts here minus 1 v naught there is 3 v naughts. And then s naught minus s naught is 0, and what's that, 3, and negative 75 is going to be negative 72 technically. So notice right here I actually have a system of 2 equations and 2 unknowns. I could actually even rename these as equations D and E if we wanted. And I think I'm going to go by elimination again. Let's see, does anyone know what number these two both go into? I don't feel like figuring that out. But I do know these ones, 1.5 and 3. I think I'm just going to multiply this top equation by, what, -2? I think that's doable. Am I right? So you could write your work that way, or I'll just write -2d as my next line here. So let's see, 2.625 times 2 is -5.25. A. What was it? -3 v naught. And let's see, -2 times 0 is still 0 in my book. And then I can do equation E minus 2d, because I'm combining them. So let's see, it's 2.25a. The v naughts cancel out, and I get, I'm going to have a sign error. Oh, no, because the acceleration due to gravity is negative because it's pulling us down. It's not pushing us away from the planet. Please. Come on, man. So divide by 2.25. And let's see, 72 divided by 2.25. I get 32. Guys, we did it right. Haha. And it's negative. Let's see, for sake of time, no, I guess I'll finish solving this. I was going to leave it up to our internet friends to solve it the rest of the way, but let's see, I know A, how could I find another variable? What equation should I plug into?
You put it into, C minus 1a,
Yeah, we could plug it into this one, or this one, or technically even this one. I want to plug it into an equation that has A, first of all, and in an equation that only has 2 variables overall, so that way I can actually be effective with it. Sure. Even though these are smaller numbers, they're more decimally. They're scary. So I'm going to just plug it into this guy here. So -32. And actually, I'm out of room, so I'm going to zoom up to the top and zoom over. And let's see, I'm plugging in what for A? -32. Let's see if I can do some, just scribble out this A. And of course, Indiana Jones would put this in a bag. -32, right? So let's simplify that. 7.5 times -32, -240. And then we could add that to both sides. So what was scary about this problem was just that it had a bunch of weird-looking variables and decimals, really. And it was a systems of 3 still, I suppose. I mean, there was still that working against it. And let's see, we'll get V naught is 56. And let's see, so now I know 56, I know -32. I need to find what, S naught? Let's see, so what's a good equation? I could plug that in. One with all 3 of them. Here's, really any of these 3 would be fine. You like C? Yeah, sure, I like C. Oh, let's see, and I'll grab a snapshot of that. Click, click. And let's see, so let's plug in what we got. So I'm going to have -32 in for A, and I'm going to have 56 in for V naught, right? -32 and +56. 8 times 32, I feel like I should know that. 240 plus 16. Is that -236? Did I do that math right? 256. 256. Yeah, I forget my second digit there halfway through the math. 4 times 50 would be 200. 4 times 6 is 24, so 224, if I'm not mistaken. I think. Combine those. Wait, 225, guys. 224. I said 224 out loud, I'm pretty sure, right?
Yeah.
Okay, I just wrote it wrong. At least I'm making my mistakes at the end of the problem. And let's see, 224 difference with 256 is 32, oddly enough, and that will be a negative 32 plus S naught equals 3. And then I could just add that 32 to both sides, am I right? So I get S naught equals 35. And then I could answer the question, but this video is getting long. It's 20 minutes already. Yikes. Yeah, you could say that the initial velocity, the acceleration due to gravity is negative 32 feet per second squared. The initial velocity is 56 feet per second, and the initial height is 35 feet. So this means we launched an object off of like a cliff 35 feet high, and it fell, and this is what happened. So there we go. That's a systems of 3 word problem right there. Enjoy. Bye-bye.